we're honored to have Daniel Hettema. He's currently the Director of Digital Engineering Modeling and Simulation within the Office of Undersecretary of Defense for Research and Engineering. So he basically oversees the strategy and policy for digital engineering modeling simulation, trying to promote best practices for the advancement of digital tools and techniques across the life cycle. So under his leadership, he's participated in, has doubled the community of practice, visited visits to the and also visits to the digital engineering body of knowledge. The DEPOC has increased 30-fold, and also he's worked on the first of its kind DoD and government agency interactive collaborative event. I believe another one's coming up this year. Daniel brings a extensive experience in both industry and government, in addition to DoD, and has supported both the DOE and IC community, and has held leadership roles in multiple professional organizations, holds a BS in Systems Engineering from George Mason, MS in Space Systems Engineering from Johns Hopkins University, and is a COSI certified systems engineer professional, as well as a level 4 SysML modeler. So we're very honored to be for him to have give a talk this month. So on to Daniel. Go ahead and take it over.
Thanks, James. That was very nice of you to kind of provide that little bit of an overview. So I'm going to walk you guys through some of what we're doing. So let me start my screen sharing here. And I have the chat open, just the joys of multi-screening. So if there's any questions, just feel free to go ahead and put it in the chat. I'll be able to answer it as I kind of work through the slides. So we can keep this a little bit more collaborative. So I wanted to talk to you guys today a little bit about a celebration of digital engineering successes, and kind of provide an overview of kind of who I am, where do I sit in the federal government, and some of my responsibilities that kind of go along with that. So the first kind of the starting point to me is when I think about it's a little bit of level setting. So if you aren't aware of who the President of the United States is, this is Joe Biden, but it's important to kind of look at kind of two key parts. Where does the president get his authority from, and where are the priorities that kind of define where he's trying to take from a national security perspective? So we can look at the authority as something coming out of the Constitution, commander-in-chief, but the priorities are captured in something like the national security strategy, which really goes through and provides a lot of structure for us in the department as we think about how do we need to drive through. But one of the things I highlight here is that his priorities is about empowering to create innovative and creatively designed solutions. He's looking for us to kind of reinvigorate and rethink about this across the entire defense industrial base. We can go down now another level. Now we get to the Secretary of Defense, Mr. Lloyd Austin III. We can continue this kind of authority priority structure and look at the authorities coming out of something like the Title 10 from the US Code. And in there, it talks about the head of the department. What are the bounds of the head of the department can do and things like that. The priorities we clearly find laid out in the National Defense Strategy, which talks about the fact that in order for us to succeed, we need to reduce institutional barriers. We need to promote interoperability, and we need to upgrade our technology, facilitating information exchange for mutual benefit. Our leaders are giving us a lot of the key signals to go on and do great things and change the way we do this. In fact, recently at an event, the new Joint Chief of Staff, Air Force General Charles Brown, talked about the fact that if we're comfortable, we're probably not changing. And that I really take to heart, because I really do feel like it's critical that as we think about this transition into doing things in a more digital engineering environment, using the tools, developing the models the way we need to be doing, it's going to require us to be a little uncomfortable. So now let's go down another level. So if you're the Undersecretary of Defense, this is the Honorable Miss Heidi Shue. She actually has a pretty broad portfolio. And you can find all that in her authority document, which is DoD Directive 5137.02. And so it defines kind of the scope, her responsibilities as the chief technology officer, and some of the other kind of bounds that she has with field activities and things like that. The priorities, once again, continuing that structure, we can find called out in the National Defense Science Technology Strategy. She says we will continue to modernize our digital infrastructure. We will harness the analytical power of modeling and simulation. They're giving us the tools necessary to continue to drive that. In fact, talking specifically about the importance of modeling and simulation in digital engineering, she has been, for her confirmation hearing, she talked about the importance of leveraging digital engineering and model-based system engineering to help fix the design, test, fix cycles that we have in the department, and the fact that it's critical that we continue to modernize the DoD's approach to systems engineering. So we're going to take a little bit of a tangent on that part, though, before I dive a little deeper into the system engineering part and talk about the critical technologies. There's 14 of them kind of found here throughout the circle. My role as the director of digital engineering modeling and simulation, I actually collaborate with a few of them, trying to provide additional resources and collaboration opportunities for how can we add value. So collaboration and things like hypersonics, helping them understand what is the best way to think about modeling and simulation. How do I connect them with high performance computing that's necessary to do that kind of computation that they're looking to achieve? Space technology. So obviously in space, we're not doing a lot. We have to rely on simulations and models to tell us the information that we need. So I collaborate a lot with them on what is the best practices. How can we learn and kind of experiment through the adaptation through what's going on in the Space Force and pulling that in. Advanced computing and software. So that's really in the how do we use these tools to kind of automate and build out things, along with things like the trusted AI and autonomy, just driving that the capabilities that we have out there and building that out further. So that's a little bit of the technology side. She also has kind of the engineering side of her portfolio within OUSD R&E. And there are kind of 4 major areas. The first one is the system engineering and architecture. I'll talk about that one in a second, but I want to talk about the other 3 kind of going around the circle. So the next top right one would be developmental test and evaluation, developmental test evaluation and assessments. This is led by Mr. Christopher Collins, and he's really focusing on kind of championing this idea as testing as a continuum. Just how do you use models and simulations to accelerate your testing, doing that during development instead of waiting until operational tests to do any of that. So that's another great success and partnership we have within the R&E family. Continuing down, another cool asset within the R&E family is the Test Resource Management Center. If you're not familiar with them, they have an awesome portfolio where they provide a lot of the foundational network and infrastructure for all the test field activities across the United States. So everything from Redstone Test Arnold to White Sands and everything in between. Providing that kind of perspective and thinking about how do we do things like joint live synthetic environments for that kind of operational testing. How do we think about multi-domain, both from the air, sea, land, space perspective and cyber across multiple levels of classification. So there's a lot of great work, and we're actually a very strong partnership with them as they build out their Cheetahs platform to really enable the kind of data interoperability and model capturing necessary to actually let programs go off and do the analysis that they're looking for. The final big one I want to call out is mission engineering. This one on an org chart sits underneath mission capabilities. But one of the cool things about mission engineering is they sit at the intersection between kind of early concepts and an intelligence perspective and the kind of systems architecting perspective. And so that they have a cool portfolio of trying to understand how do we ensure that the capabilities that we are acquiring on the technology side really meet the need, and the fact that as a defense department that they aren't going to be overcome by other intelligence perspectives, making sure that we put the right dollars in the right place. So now I'm going to talk kind of about my direct boss in the system engineering and architecture. So my direct boss is Mr. Tom Sims. We continue to that story about of authority and priority and looking at something like the DoD directive, and really talks about advancing and developing policy and practice and workforce competency for a wide variety of things. You can read there that mission statement. One of the cool things you'll notice here is the fact that we report directly to the Undersecretary of Defense for R&E. That's a huge change. Back during a 2022 reorg, if you're kind of familiar, system engineering used to be buried kind of fairly low. That has now bubbled up because our senior leaders recognize the value that systems engineering has as a community to the department. And so we are now part of that first line of defense. In fact, the Honorable Shu actually spent 4 to 5 minutes at a recent technology conference talking about the need of systems engineering to ensure that we add the necessary rigor in our investments and be the connection around things like MOSA and digital engineering. So the System Engineering Architecture Executive Directorate, we have a couple major areas. Each one of those gears has their own specific government director. So for specialty engineering, it's Mr. Chris DeLuca. He's really focusing a lot on things like civilian harm, manufacturability, survivability. A lot of the cool parts of the ilities all roll under him. And so he has a pretty broad perspective. We collaborate very well when we think about the importance of models and simulation and kind of that sustainability aspect, bringing that perspective into that early acquisition. Going around that kind of gear curve, we'll go to software engineering. This is led by Mr. Alan Dianic. He actually has just released an API kind of strategy and is building out some API guidance on how to think about the importance of APIs when we're building out the various tools, and does a lot of great collaboration both with the CIO from that kind of information technology perspective and also the chief data officer and that kind of intersection of all of those disciplines in that software engineering field. Moving around, we have a director responsible for kind of overseeing and managing a lot of the broad strokes of the policy and workforce development. This is Mr. Rob Lorino, who came in recently to us. And so he oversees and kind of coordinates the various scopes of policies and strategies and guidances that we produce as the entire executive directorate, with obviously each of the directors kind of taking the lead in the specific discipline part. The joint architectures for capability and systems. This is really about it's a new directorate that we kind of stood up recently, focusing on how do we add some additional value in this kind of architectural space. The neat thing about this is the fact that adding a lot of additional value in programs like NC3 and CJET C2 of how do we kind of help bridge the gap, actually provide tactical value to the practitioners that are trying to do the job in these major programs. Moving around the curve, we get to the systems engineering department. This is led by Ms. Nadine Geyer. She focuses a lot on things like SE modernization, the CERC, the System Engineering Research Center, and the ERIC, and MOSA all kind of fall under her portfolio. But a lot of great collaboration there too, from my perspective, because we focus on as we think about SE modernization, it's important to realize the use of models in that, which requires us to change our processes. Going around the curve, Defense Standards Program. This is a partnership with the Defense Logistics Agency, DLA, where kind of overseeing the broad scope of standards that we have. This is led by Mr. Michael Heafy. He has the responsibility for the ASSIST database, if you've heard of that and gone there, the kind of listing of all the broad scope of standards that the department has to manage. And finally, we get to myself as the Director of Modeling and Simulation. So continuing down the chain, we can kind of start seeing where my authority pulls from. Some of my authority comes from the R&E Charter, because it talks about the providing workforce competency for the digital engineering, modeling, simulation capability. But additionally, we can look at something like the DoD Instruction 5000.97, and I'll talk more about that specific one a little bit later. The fact that establishing the policy, guidance, and practice around the skills necessary for digital engineering. And you can see kind of my priorities are really driven by adding value to the practitioner. I come from being a practitioner myself across the federal government, so supporting the DoD, the IC community, Department of Energy, and things like that. And we go back to, I'm trying to make sure that I'm adding value to the practitioner. As a practitioner, I always think about the fact that practitioners want three things. They want time, they want tools, and they want data. None of them has ever said, I'd like more meetings, I'd like another boss, I'd like more emails. And so we always measure ourselves based on, are we adding value in kind of those three major areas at the practitioner level and meeting the challenges that you guys are telling us and providing reasonable solutions that we can achieve. So a little bit about kind of my organizational history. So many of you probably know my predecessor, Ms. Philomena Zimmerman. She's actually that red line right there. The blue line is actually a part of the portfolio called the Modeling and Simulation Coordination Office. That blue line actually traces all the way back to the 90s, back when it was called the Defense Modeling and Simulation Office. It's gone through some iterations and changes. Kind of in the mid-2010s, the most recent director was Jesse Citizen, and all the great work he did in kind of corralling the various modeling and simulation parts of the department together and actually trying to drive in and incorporate modeling and simulation. To that end, when we think about the role that MISCO had, one of the key objectives it had was incorporating modeling and simulation technologies into kind of the department across the various functions and activities. A little bit of a sidebar kind of history lesson for you. Back in the mid-90s, the Congress created an M&S caucus. It still exists. The chair is Bobby Lee out of Norfolk. And I forgot the other one, but the Upper Peninsula of Michigan are the two co-chairs. And so during the 90s, they actually established modeling and simulation as a critical technology, and a lot of great work has happened since then to really imbue modeling and simulation into the disciplines. So much so that none of us sit around going, oh, well, should we do this on paper or should we do this in some sort of digital model? It's now more about how do we make sure our digital models are accurate, coherent, and interconnected. It's not about transitioning that. So from that perspective, MISCO was a major success. So in the mid-2022 timeframe, the SES over this the system engineering portfolio was Ms. Stephanie Pacell. She actually kind of looked at these two portfolios and went, wow, there's actually a lot of overlap. This engineering tools environment, red line, modeling simulation coordination office, they should really be combined. Since then, I've come in to continue that combined effort and really focus on the benefit of a single resource to amplify each other, because there's a lot of lessons learned from one community that can be applied to the other, and there's a lot of great push and pull that comes together when we have this structure. So how do we come to this conclusion? It wasn't just kind of a out of nowhere. We actually did great analysis at the time on the various pain points. So you can see here the pain points that were collected from the modeling simulation community and pain points that were collected from the digital engineering community. If we take those pain points and we just simplify them a little bit, what we find is the fact that they're actually very common to one another. And so there's a lot of overlap. And so my portfolio, I focus a lot on how do I address those key points in the middle, the overlap, because that's where I'm going to get the most bang for the buck, thinking about adding value both in the multiple communities that exist. If you're familiar with the modeling and simulation side of that portfolio, though, the communities are pretty broad. There used to be what's called the 7 surfboards, the 7 kind of classic areas of modeling and simulation, planning all the way down to training. You can see them on the left. As we kind of look to where we're trying to drive the conversation, we're actually simplifying it down to 3 classic areas. I call this slide a little bit of a back to the future reference, because if we go all the way back once again to the 90s, that's how we actually started. We started in this kind of application of modeling and simulation around for the uses of analytics, for engineering, and for training. And so as we're trying to map and we're coordinating with the various communities, understanding their needs and concerns, and does this kind of mapping fit as we drive this capabilities back. One of the things that we recognize is the fact that from looking at the seams of 7 is just too many seams for us to kind of manage at the department level. 3 seams is much more manageable for us to have Additionally, it lets us push the kind of collaboration back into the functional areas, and then really let the kind of organization focus on the foundation pieces that are consistent across it versus having to focus on the challenges of any specific domain. Additionally, when we actually take those pain points and we kind of spend some time looking at them, what we find is that the needs are different as we go. So for example, what you see here is the engineering community. When we go talk to the engineering community and kind of analyze their needs, what we found was the fact that a lot of the needs was more about the challenges around incorporating models and simulation and kind of digital thread picture was a culture challenge. It just, the culture wasn't there, the integration of the models, everyone has their own preferred tools. Those were the challenges. The technology, for the most part, was there. We can go look at commercial industry and see what they're doing and kind of go, man, we could be doing all that. We have sometimes that capability, but we're doing a poor job of integrating all that across that acquisition lifecycle. Contrast that to something like the training community. The training community already has a culture that's very adopting of technologies. They're the first to jump into things like the live virtual constructive, the use of kind of models and workforce competencies of building out these models. They're there. But a lot of their challenges are driven around the technology. The fact that, well, we're not quite yet able to create lightweight AR goggles. We're not quite yet able to run these to make realistic simulations and fighters, and it's a technology objective more than it is a workforce objective. And so this is all part of the story that kind of goes into just the how we're structuring and why we're focusing on these various things. The analysis community kind of sits in between for kind of the engineering and training community. They have a little bit of the integration problem, a little bit of the we don't know where some data is. The technology is a little bit kind of wonky. So for example, as I talk with people out of the Center for Analytical Planning, CAPE, they have a need, but some of the times their needs are, well, we're trying to run massive simulations that take a long time. Sometimes it's, well, we just need to do like simple Monte Carlo simulations, but we don't have the data. So they're kind of a little bit of in between the kind of two extremes of the engineering and training community. Within kind of my primary focus, I'm focusing on trying to help address and bolster the engineering community. I'm looking at the OSD level to my CAPE counterparts. They're bolstering the analytics community, and then my P&R counterparts, personnel and readiness, is really bolstering that training community. And then I'm focusing on, as we collaborate, focusing on the seams to really make sure that we all meet each other's needs. Well, part of those needs is really understanding kind of the scale of policies that we have. And one of the things that the team did is we went and looked at the fact that there's over 709 policies in the department that talk about modeling and simulation. Now, I don't want you guys to think this is a detailed, like it's a clear directive of go do modeling and simulation, but at least there's 709 policies that reference modeling and simulation. One of the things that I always come back to as a practitioner, and when I think about what my role is at this OSD level, is, well, why aren't we achieving what we're trying to do? Why aren't we seeing the adoption of models and technology in this digital threads as what we need? Do we really need 710 policies? Is that the gap? Or is there other cultural challenges that are preventing us from achieving the target of this that our leaders are laying out for us? We saw as we kind of walked through that our leaders are looking for creative and innovative design. They're looking to break down institutional barriers. They're looking to invest in our digital infrastructure. And it's like, well, why are we running into all that? How do we look beyond maybe policy to address some of that? So with that, one of the things that I like to do then is I recognize that policy is an important part of my portfolio, but like I said, policy isn't always the answer. And so I'm going to talk a little bit about some of the efforts that we're doing internal to my team to really drive that change. So we've done some kind of structuring of our pain points. I'm going to talk about a few of them, kind of you can see here. The ones in gray are the ones I'm going to kind of skip over. That's not to say that we're not doing a lot of great work. Collaborate a lot with the simulation interruptibility standards organization. working with them and thinking about how do we incorporate kind of their experience from simulation interoperability into some model-based system engineering simulations. Object management group, so the coordination on things like the reference architecture, coordination with the kind of most of the work that they're doing, IEEE, ASME, so a lot of great work there. Measures of success, ROI. One of the cool things that we just really was a sponsor for was a RAND study around kind of building a framework for measuring, thinking about how do you measure ROI. So that's another cool one that we've done, collaboration on things for DE work roles, CIO coordination. There's a lot that we get going on. I could spend hours talking about all of them, but I'm just going to run through a couple of them and then really talk about some of the other successes that we're seeing across the department. So the first one I want to talk about is we kind of think about that the multi kind of perspective of the department. Obviously, the department, we have to have some sort of overarching strategy that helps lay out the vision of where we're going. So we're developing a modeling and simulation strategy, really focusing on the engineering needs within that construct. From that perspective, it's everything from that kind of mission engineering perspective through architecture and systems design, through the discipline engineering, through the use of developmental test evaluation, verification, validation, into the early stages of the manufacturing. And so that's all part of that broad perspective of how do we imbue the kind of necessary strategy around the use of models and simulation to drive that change. So you can see here, these are the 5 goals that we currently have as draft. We're targeting a release of kind of late summer, may slip kind of to early winter, depending on kind of just timelines of getting signatures, because that does take a while in the department. But this is really trying to help set the bounds of providing the tools necessary for the services and the field activities to connect and start thinking about, well, how do we do better modeling and simulation in this engineering construct? Moving down a level, one of the policies that we own is the newly released DoD instruction 5000.97 digital engineering. This was released December 23rd, so it was an awesome Christmas present. And so its really purpose is the fact that as we think about transforming and incorporating digital engineering, the fact that we now have a policy that directs programs after the issuance, so basically at the start of the year, must incorporate digital engineering during their development. There's always the waiver options, but we're moving that ball forward. This really helps us set that milestone that the department is serious about digital engineering. We're embedding that into things like the system engineering plan. One of the other cool parts it calls out in there is the role that TRMC, the Test Resource Management Center, has in incorporating and being one of the key providers of digital engineering capabilities, meaning kind of tools and infrastructure, and providing some additional top cover for the services as the Navy develops things like the IME or the Air Force develops things like Platform One, Cloud One, things like that. So we're very proud to finally have that first digital engineering policy, that instruction out there to really set that milestone for the department. One of the other ones that we have is 5000.61 verification, validation, and accreditation. This really talks about how do you think about this for modeling and simulation and the importance of it when we do our models. One of the lessons that I've kind of learned out as a practitioner is there's all sorts of policies out there, but this is actually an opportunity from the M&S side of the house to help influence and share some key lessons learned to the digital engineering side of the house, the kind of systems engineering perspective. One of the key areas for that one is really this idea of uncertainty quantification coming out of the statistic realm and operational test and evaluation. But it's how do we bound and understand how certain we are, so uncertainty, how do we quantify that in some sort of measure to actually provide better constructs for the program managers to make informed decisions. And so some of that's embedded into this update that we're working. This should be out very soon. You guys can tell the fact that like we've been working on it for quite a while. Just it takes a long time to go through all the checks that have to happen in the department for for legal sufficiency, for lawyers to review it and everything else. So it's taken a little bit longer to work through some of those steps, but we're very excited that that should be coming out very soon. Another thing that we're working on is we have a DoD Mill Handbook 539. This is really about trying to provide some of that middle tier instruction. So there was a first version that that was developed primarily through some Navy collaboration, that we're kind of pulling that thread and really rebuilding that as a kind of cross-department perspective, and thinking about the importance of how do we provide some next level guidance and recommendations for programs as they adopt these digital engineering techniques and tools, and provide that in some sort of structure that makes a little more sense. So this is an open working group that's actually being developed. If anyone wants to be involved in some of this, please reach out to me. I can get you involved with the team. Obviously, we're pleased that we're making progress on this, because we want to make sure this is valuable to you guys in the community. One of the other cool things that we've done in the system engineering and architecture family is that we've created a model SysML version of the FAMICA model. Just a lot of acronyms there. Failure modes, effects, and criticality analysis, which is actually the first time, and we're actually able to load this into the ASSIST database, which is the first time that a non-PDF version of a standard was loaded into the ASSIST database. And it's a little bit of a kind of wonky way we had to do it, but that's not important. But the point is that we actually have it in there, and that we're trying to help coordinate and demonstrate as we think about what the future looks like, the fact that delivering these PDF flat files for standards really is in the future. How do we start capturing some of these ideas in more representative models? And so this is our first try at that as we continue to iterate and learn. And we have great collaboration with a lot of the standards bodies like IEEE and ASME, where they're thinking about what does a digital first standard even look like, and how do we help be a pull on that from those standard bodies. Another interesting kind of piece of work that we're doing is called Detect, which is not spelled out there, but it stands for the Digital Engineering Tool Selection Criteria, I believe. Maybe missing something in there. But what it's driven is, if you look at the 5000.97 policy, in it talks about the fact that, hey, you should go look at existing ecosystems prior to standing up your own. So we actually have kind of two parallel efforts going. One effort we're trying to figure out is how do we provide a good index for what are the ecosystems that are out there. So we're trying to address that need. But then the other part of that is, how do we actually then better answer the, well, what should you go stand up if you decide to go stand up? One of the big observations I've had is that as I communicate with the services and the various field activities, the needs of programs and various offices change depending on kind of the size. And so one of the cool things that we're doing is we're kind of t-shirt sizing it. And so we're trying to make sure that we provide some clear guidance around things like, hey, if you're a small team, you should go develop, then this should be part of your criteria of selecting the right tools that meet your need. If you're a medium team, if you're a large team. Because what I don't want is some sort of guidance that is so generic that it's not practical, but at the same time, the needs from an ecosystem is very different from a small 3-man team at Redstone Test Arsenal than what it is for a program like Sentinel. And so we're trying to make sure that we have that kind of separation, because there is some commonality, but it just trying to drive in that the needs are a little different and capturing some of that. So this is work that we're doing. We're actually spending the time to model it out, provide the traceability back to work that's occurred across the department, be it the tool selection criteria that was produced under the ETE banner a couple of years ago. We pulled work in from some FFRDC partners, Aerospace and MITRE, on some of their ecosystems that they've kind of built out and structured. And so we're pulling all that together and going, how do we actually drive this need and provide tools necessary to help you guys make better decisions around what is the right tool suite and ecosystems for your need. Kind of continuing the thread of being useful for the community. One of the big things the community said is, as we look at the System LV2 that's coming, we need to think about how do we transition. And so this is a great partnership we have where we on the team, I actually have Sandy Friedenthal through some support through the Navy. We actually have a great collaboration team on this one across all the services, some federal government, NASA, Department of Energy, some of the labs are included in this as well. But when we think about the System L transition, we did some very rough back of the envelope math just across the 3 major ecosystems in the department. So just 3. There's 15,000 models that are in System L version 1. So that's just in 3. That doesn't include major programs that have their own ecosystem. That doesn't include field activities. That doesn't include contractor developed models that will all kind of fall under that. So realistically, we're looking at the fact there's probably north of 30 to 45,000 models out there that are going to be affected in some way by this transition. Additionally, when we kind of crunch those numbers, we looked at about a quarter of the engineering workforce is going to be affected, either as a developer, a model builder, or as a model kind of product receiver. And so how do we think about that? Because the needs of someone receiving these models as System LV2 changes into more of a kind of structured approach, that's going to require them to change on the receiving side too. So we've been collaborating. You can find all the products for the System LV2 work on the OMG Wiki. So there's a question about where we can find some of these documentation. Any place where we have things publicly available, I think we put a QR code on the slides. The slides will have publicly available for you all to go find. If it's things where it's either CUI or it's still in development, you can just go ahead and email me or someone on my team, and we can coordinate with you to give you either bring you into the working groups or give you access to some of the other products. So one of the products that I do have is the Digital Engineering Body of Knowledge. This has seen a lot of great growth across the department for how do we incorporate and provide the resources necessary. Previous versions of this was actually locked behind a CAC card. The community came to us and said, that's not super helpful. We really need this to be more open. So we went and created this DBOC.org, DBOC.org, de-boc.org, excuse me, website, wide open and really meant to be a great resource. We have a steering committee from universities and other federal agencies that are all participating, and we're continuing to grow that content. We're incorporating more modeling and simulation practical experience into that kind of as a resource. Some of our development roadmap, as we kind of think about this DBOC, is one of the things is we want to provide the tools. We want to put this in at your fingertips at the levels the department works at. So I was at the National Reconnaissance Office, which if you're familiar, not everyone there has access to unclassified computers. And so there'd be times that I'd see good engineers have to walk out to their car. It's a 5-minute walk from their desk to their car to go Google something on their phone, 5-minute walk back for them to try it. It doesn't work, 5 minutes back. And it just, that's the kind of challenge that I'm going, how do I make sure I provide these kind of necessary experience and knowledge at the right network so that way everyone has access to them. So we have a roadmap that incorporates kind of moving this data from an unclassified structure, adding a CUI layer, moving that up to a CIPR network and all the way up to a JWICS network. Just working through a lot of that. And that's just all part of the fun that we're having. So the DBOC is a great resource. If you haven't been there, please go there. That's one of the great successes that we've had. Another product that we kind of work through is our digital engineering modeling and simulation community of practice. This used to be kind of more focused around when it was called the DE working group, under the kind of ETM flavor, ETE flavor, excuse me, was more focused on having each service come in and talk. We shifted that once again to add value back to the participants around more thematic things. And so we've done previous one on things like workforce experience, on things like tools and ecosystems and stuff like that. And so this is now an every other month approach. And so coming up here in May, we're actually going to be talking about AI, large language models, and kind of their role in this digital engineering ecosystem. And what does all that look like? So that's one that we're really excited for as we continue to build out that. And this is really meant to be a resource for the community. All of these topics, both last year and this year, came directly out of the community saying, I want to learn more about blank, or there's not enough knowledge being shared around blank. And so that's where these kind of great ideas come out of. And so this is an opportunity for the community to hear and talk to each other of what's going on. Continuing that idea of how do I provide venues for the community to talk to each other, one of the cool ones we had in October of 23 was the Federal Digital Engineering Forum. This brought together about 200 attendees over multiple federal agencies. So we had Department of Homeland Security, all the military services, Department of Energy, we had NASA, all like, I didn't quite get a Department of Forestry. I was looking for that Department of Interior, Department of Forestry person. Didn't quite get there. But we brought in as many of them as we could find to talk about what they're doing in digital engineering. We did 10 working groups where we really talked about the challenges that we're having. And this was an awesome collaboration. The unique thing that we did was this was at the controlled unclassified level. Really what that let us do is have some more honest conversation in the federal government of what is working, what are the budgetary constraints that we're working on. Some of the lessons that came out of this for us was the fact that what is unique for us as the federal government is that every 4 to 8 years, we get new leadership. And with that new leadership comes new priorities. And it just how do we design some of these initiatives to be executed within those timelines? Because just we've all seen these kind of startups where we go, oh, we're going to do this, and then a new administration comes in, wipes that kind of clean, and it's like, well, we never quite get the momentum going to do that forward. So it's like, how do we plan for that? And so that's one of the cool things that we had during this discussion. This is going to be annual. I put annual in quotes. Working right now with some other federal agencies to maybe host an October one. I'm shifting this one specifically to the spring. You guys are kind of in the Washington D.C. area, obviously Baltimore a little bit more, but the whole government shutting down in October, kind of want to avoid all of that. So we're going to move to the springtime. Right now we're looking like for about middle of March is what we're targeting. As we get a little closer and we lock down that date, we'll definitely keep everyone informed, because this was a really great event thinking about how do we share and collaborate across the entire federal government. So you can see that's a lot that we're doing, and obviously I didn't talk anything about how we're updating things around UAF and collaborating with the CIO. Didn't talk about some of the challenges in the communities that we're doing around thinking about how do we provide incentives to get programs to do changing, how do we talk about collaboration and resourcing and things like that. And so that's all for just a whole other presentation I can do just on some of those topics. One of the things that I find when we think about this adoption is at times we get wrapped up around the challenges that are big challenges. I was at an event recently and someone was like, well, the problem with digital engineering is we can't adopt it until we solve the security problem. The fact that it takes us too long to get clearances and things like that. And it's like, it's hard because there is a root of that challenge, but they are such massive problems. And so one of the things that I very much like to think through is, yes, there's big challenges, but we can go to literature and kind of look at, well, how do you tackle those big challenges? It tells you to start making changes local. Make changes local, and those local changes will result in changes at the next level up, the next level up, and next level up, until finally you just create that momentum across the department. So I don't want to talk about, when I think about how we celebrate successes, it's not about we can't do digital engineering until we select the tool. It's, well, let's focus on doing something today. How do I empower people to go off and make some sort of change that drives the conversation forward? So one of the things that I like to think about is, what have I done to change? So I come from being a practitioner. I've built my models. I've done my time in the trenches, building out my STK models, running it through Monte Carlo simulations, yelling at my Python code, going, why aren't you working? Only to realize it wasn't the computer fault. It was my poor programming skills. So I've been there. I've been part of that. But as I moved into this position, it's required me to change. It's required me to shift and rethink about how I apply my skill set and how do I add that value. I've had to learn more about things like the financial side, the kind of communication and collaboration building more than I have in the past. But that doesn't mean that we don't lose sight of how we can actually do small changes of incorporating the principles that digital engineering and the use of models really provides. One of the kind of frustrating things that I have is Outlook calendars. I maintain kind of my own personal calendar of where I'm at, because I bounce around to all sorts of locations. There's a separate office calendar that we maintain that says where we're at, and team calendars and all those things. And I was like, I am updating my calendar so many times. Why do I not have a single source of truth dedicated to my location? And so we took the initiative and I went, I'm just going to write some VBA code that syncs the various calendars in alignment with what my calendar is. So that way I'm not spending time having to fiddle with calendars. We're trying to drive that conversation. So I've taken this kind of mentality and I've pushed this into my team across my portfolio within digital engineering modeling simulation. We've revolutionized a lot of how we've thought about stuff. We're incorporating more social media presence into our work. We've done really pushed hard into the application of Microsoft Teams, good, better, and different, and how you feel on that. We've done things around book clubs. So how do I help communicate my perspective down to my team of, this is where my biases are, this is how I think. We're doing things like Email Free Friday. If you haven't done an Email Free Friday, recommend you do that. And the first time we did it, and it's continued, I saw about 60% reduction in email just on Friday. And that was just mind-blowing because it forced us to collaborate in different ways. It required us to actually use Teams to make a phone call, send us a chat message, and drive some of those things. We've actually been able to take our successes here and move that up a level, move that up a business unit level to SC&A. So now we've demonstrated how to do a task tracker. So my kind of parent business unit has really started incorporating a lot of the kind of task tracking capabilities of Teams, really incorporating from the application of social media, where we're becoming kind of the stewards of how do we demonstrate social media value to other parts of SC&A, get them to do similar things to grow the awareness and collaboration across the community. The digital engineering body of knowledge continues to grow, and collaboration as we think about what various other bodies of knowledge in the kind of I think the CERC, Stevens maintains the SE box. So how do we continue that collaboration? The development of things like a specialty engineering box, collaborating across the department on all those great things. It's not to say that everything we're doing, my business unit has kind of mirrored things like the book club. Right now, it's very much focused around kind of my team, but that's something that I've given my books to my boss to help get him to think a little differently, to get him more prepared for this digital transformation. And so these are all the small steps that we can take internally to make these kind of big changes. We can continue flowing that up and think about the R&E family and see all the great work that's happening there. where all these small successes continue to grow. Developmental test and evaluation. So I talked a little about this idea of testing as a continuum. Underneath that is modeling and simulation as a continuum. The importance that he recognizes that in order to have this kind of continuous testing, we need to have a robust ecosystem for us to do the model development and model sharing and understand the bounds of those models. TRMC, the work they're doing with cheetahs to drive a lot of that joint live virtual constructive efforts is really critical, that they're bringing in mission partners and going, how can we add value to you across the department? How can we demonstrate how you can pipe your data and actually connect your various models and store them and run them on kind of cloud computing architecture so that you get some additional value. The Joint Federated Assurance Center is another awesome part of the R&E portfolio, thinking about, as we think about the scope that the department has, how do we assure that what we're doing is robust and is built around kind of a holistic picture of success instead of it just being just hyper focused on a pure delivery. And then mission engineering, you go look at something like the Mission Engineering Guidebook version 2, which just came out. Embedded all throughout there is this application of modeling and simulation, moving us out of these massive PowerPoint diagrams, these Visio diagrams, into robust digital artifacts that really enable us to understand and condense and think about all the data that we have to analyze. We can look across the department. We're seeing the Air Force taking huge leads out of things like the Digital Transformation Office out of Dayton, Ohio. The synergies that they have both on the civilian and military side with General Richardson and their service executives to shape and think about the digital material management of how do they think and drive that change to happen across the department. The Navy is investing in things like the integrated modeling environment to really provide the tools necessary for the departments to achieve the vision. That's only one part, though, for the Navy. The Navy is also further ahead in things like with around the kind of application of AR and VR. If you've ever gone down to a shipyard nowadays, they're surprisingly technologically advanced. That welders can now pull up an iPad that has a VR capture of the ship to understand if I start cutting into this wall, what's on the other side? Am I going to damage anything? And they're able to kind of view and understand all that. So the digital twin capability that they have at the shipyard is very impressive. And the armies continue to grow their capabilities, specifically in things like MOSA, and thinking about how do they apply that perspective across their fleet of vehicles, both air and ground, and incorporating the need for interoperability and thinking through the model approach and what does it mean to have digital models that connect and have such a long lifespan, such that we're going to continue to operate them and improve them in the kind of scope that we have when we think about the ground vehicles that the Army maintains. And we can continue going up another level and think about the scale that we're seeing changes. NASA is changing their kind of approach. They recently created a position at NASA headquarters dedicated just to the application and the transition of digital engineering. That's another great success, but they're seeing the value. They're trying to drive that in across the various the centers that NASA has. We can look to the universities. Something like the University of Arizona is doing some really cool work where they've started to recognize that as they train up their engineers, that these young engineers were still having to kind of do this still deliver us a PDF of a model. So they've built out their structure and their testing at they're doing some initial testing of how do they actually have it in such a way that the professors can be in the models, providing the comments, be checked in and delivered in such a way using things like Git, using these kind of approaches that are derived and are true digital native instead of it being deliver us a flat files. Wichita State and NIAR is doing a lot of great work around digital twins. We're seeing the fact that they've taken a B-1 wing, they've 3D scanned it, and now they're comparing it against to create 3D models, and then they're comparing against the physical strains to understand how accurate their models are as they produce some of these digital twins that can be used to accelerate kind of sustainment activities and manufacturing activities that we've never been able to do before. And so they're doing a lot of great work, and we continue to see awesome research being produced out of the system engineering and the acquisition research center, the Cirque and Eric, around thinking about what does the future of system engineering look like? How do we reframe the acquisition approach, and how do we continue to make all this great change? It's really impressive to see the entire Defense Department continue to change all of this. So that change is good. We're seeing the change. But as I'm talking to you guys here today, I want you to recognize that you on this phone call have most likely already drunk the champagne. That you believe in this kind of idea of digital transformation, that we should be doing modeling and simulation. But that doesn't mean that we don't need to lose sight of where the real audience is. In the Defense Department, there's over 700,000 federal DoD civilian employees spread across 50 states and beyond. Only about 10% of that exist in the greater Washington, D.C. area. And so part of my mission is to help communicate and get out there beyond just the DC area and the DC bubble, because the people who we need to convince aren't sitting here. They're sitting in all these other, they're trying to make changes in these 3, 4, 5, these programs across the department that exist in the states that, many of the states, Texas, California, Florida, Alabama, and places all over. So the scale is massive. It's critical that we go out there and talk with the community and continue to grow it and demonstrate value to them. My final kind of key takeaway for you is a little bit of a history lesson, and to make sure that we don't fall into some pit traps. If you're not familiar with the Office of Strategic Services, OSS, it was the predecessor to the CIA, created under FDR during World War II. They released in 1944 the Simple Sabotage Field Manual, which was actually only declassified in 2008. A really interesting read. As a sidebar, talks about like how to sabotage, all sorts of fun stuff, everything from your manufacturing to like how do you sabotage a dipstick like on an oil. It's really cool. Go read that one. But the part I want to highlight out for you guys is how to sabotage an organization. And I highlighted 3 specific quotes directly out of the sabotage manual. The first is the fact that you should insist on doing everything through channels, never permit shortcuts. Second one being, when possible, refer all matters to a committee for further study and consideration. And third big one is advocate caution, be reasonable, avoid making haste. When we think about the scale of the DoD, it's hard to make changes. Too often we run into these challenges. And I think it's critical that we continue to push the culture. The leadership is directing us. Once again, the Chairman of the Joint Chiefs of Staff said, if we're comfortable, we aren't making change. We need to not accept the challenges and the barriers that are put in front of us as we continue to drive this transformation that's needed, so we can be doing the good work that we need to be doing and delivering capability to the warfighter faster. Because in a near-peer adversary structure that we have in today's world, the rate of change is faster than we're prepared for, and we need to continue to drive innovation at every step, and having models and simulations in that digital ecosystem is the way we're going to help address that on the engineering aspect. So with that, I'll open the floor to any questions. I'll be more than willing to answer anything you guys have. There's how to contact us. Go visit our website at cto.mil. And obviously visit the DBOC is a great resource for anyone doing digital engineering. So with that, I open the floor to questions.
Well, first we wanted to thank you. The NCOSE Chesapeake chapter wants to really thank Daniel for coming out. We're honored to have you as our tonight's guest speaker. You really provided some great insights on very significant efforts across DoD with potential very, very significant long-term benefits to expanding digital engineering modeling and simulation. So very impressive indeed. So I guess I'll start with one question. One of the biggest obstacles I've seen is the skills gap, essentially. So I know DAU, Defense Acquisition University, is standing up a new digital engineering curriculum. What else? And I said that, and I appreciate your work on building up collaborative communities for modeling and simulation. What's your take on additional things that can be done to upskill the DoD workforce?
Yeah, so within the SCNA portfolio, we are actually the ones that write the credentials necessary to achieve the back to basic structure of the DAU. So we have a strong partnership with the DAU community because we write the credentials that says, hey, I'm an 801 general engineer, which probably means nothing to most people, but that's what it is. So, hey, I'm required to be an ETM engineering level 2. Like, this is what it means. We write the credentials around all that. DAU produces the content and courses necessary to achieve those credentials. And that's kind of the partnership that we have. We work closely with DAU to help address some of those, of making sure that the courses that they're building are actually meeting the need. One of the ones that we're helping, they had and it's not the digital literacy. There's another one that we're actually in the middle of working with them on updating, kind of improving based on some feedback that they received. One of the challenges that we're still having, and this is just a challenge across kind of the entire broad community, is these courses are really interesting and they're good, but it's always sometimes hard to get the program manager to take them. And so that's where we're trying to find additional outreach opportunities where how do we go talk to the program manager? How do we go demonstrate the value that this digital engineering provides in risk reduction to the program manager? How do we communicate all that? Because we all know all this, we're learning all this, but we're still learning it in these kind of engineering or modeling simulation pockets. We're not quite growing it to the support apparatus that's all around us.
Yeah, thanks.
There's a chat question out there. Over.
I saw, let's see, there was one from so Holly Collins is on my team. She's actually one of my amazing outreach lead. So you can email her. I don't know if I will type my email to.
And while you're doing that,
I will say though that I am very bad at email. So if you actually want a real, I will eventually respond to you. It just may take me a couple days to finally get around to it. If you want quicker responses, probably reaching out to someone like Holly on my team will institute a faster response than emailing me. I get too many emails. Once again, I don't like emails because as a practitioner, I want data, tools, and time. Emails was not one of those. So, do you think the current architecture of PLM vendors are up for the challenge of the digital thread, digital trend? What is the role of cloud vendors play in your vision? So I think, so I'm actually talking coming up here to a PLM event and really trying to understand a little bit more of that question. I think they recognize that as they think about product line management and then the incorporation of more of that product line engineering, that it requires them to reshape a little bit of the way we do some of that push and pull. One of the lessons that we're learning that we're going to document and help share is thinking about how do we do version control and sharing kind of air-gapped environments. That's one of our biggest challenges that we find in the department is all of this works great if you're on the same ecosystem. The scale of the Department of Defense, that's never going to happen. $850 billion, that's never going to have a unified ecosystem. And so it's how do we think about some sort of branching, emerging approach that works in an air gap structure. And that could be across from government to contractor, that could be contractor to sub, that could be up and down classification levels. And so that's that's a activity that we're working on for kind of a little bit later down the road to help provide some additional structure as we continue the collaboration with the PLM community. What are the related tools you see for the DoD setting? For example, is Cameo more or less the default tool for MBSE? There's a lot of great tools in the department for kind of doing model-based system engineering. Everything, Cameo is one of them, Spark CA, Rhapsody, InnoSlate, or Viatech Genesis, because Core is the old, no, Core is the old one, Genesis is the new one. They're all good. They all have their needs. One of the things that, as I think about what the future looks like for me, is we're focusing on, once again, in alignment with that S&T strategy, is the importance of standards. Of, hey, go do whatever tool that is the right tool for you, but we're going to help provide that guidance and bounds of these are the standards that you should be using, and trying to shape that perspective, because that's where the value is. I recognize that having chatted with program managers sometimes want the easiest solution that gets them the quickest delivery. My job is to look at it from the enterprise perspective. How do I make sure that the engineer 20 years from now has a model of a submarine that they can actually do something with? And if it's locked in a tool vendor proprietary format, that doesn't help us. And so that's where I'm going to have to put some boundaries, some bumpers around kind of the application of standards. And that's all part of my kind of vision, less than focusing on any specific tool. It's about setting up the boundaries of standards and things like that. One of the challenges that I've seen is the lack of data transparency in tools and the ability to share that data. I see the lack of common ontology is necessary for the establishment of a single. What is your view on this idea? So I'm a big fan of ontologies. The ontologies are good, especially when they are constructed around coherent functional discipline. So for example, coming out of University of Buffalo is one of the great ontology schools up there. But they have a lot of experience in either like the chemical and biological fields, and I've seen good ontologies coming out of very narrow disciplines. And so like aircraft maintenance has some ontology work that's happening. And so that's all good. My concern when we think about ontology is the scale that the system engineering discipline has to operate at. I don't know if there's ever really going to be a perfect ontology that meets the needs of the systems engineering discipline, let alone the broader engineering discipline. I think I focus a lot more on the how do I at least start capturing some of the semantics and driving that standardization. If you guys haven't seen a presentation from Dr. Jason Cook out of the Army, he has this kind of maturity model that he's developed and kind of tested on and actually ran on programs at the Army. But the part that he's added compared to something like in COSI that I really like is the idea of standardization. Before you go from like in the COSI model-based capability matrix, that CMMI approach, it's kind of like, okay, you're digitized and then magically you're integrated. And he's like, no, there's a step where you have to like standardize your business processes. And like, that's the big step that as I think about the application of how do I drive that conversation? Because once we start standardizing, then I can try to drive that semantic interoperability that ontologies really provide. How do you see the efforts interrelating with the soon to be issued, which puts AM&O and the two top measures for sustain? A good question. I'm not overly familiar with that specific instruction. That would probably be more in my Chris DeLuca's camp, his role in specialty engineering. So I'd have to refer that question really to him. That's kind of more in him. So, and thank you. Okay. I think I got all the questions. Any questions on the phone, virtual phone?
Hey, Daniel. Oh, sorry. Hey, Daniel, this is Hayes Bowling. I think we met before earlier this year.
Yep.
My question is, when you're trying to start, if you're trying to start a digital engineering approach at a federated level at your organizational agency for the first time, um, what approach would you say you should take to kind of scope what you're going to digitize versus trying to attack everything at one time?
What approaches versus trying to attack everything at one time? So where would I start? I would definitely start with, I think the Navy has a federated model, like white paper overview. I don't know exactly what they call it, but it's on their APN site. Make sure you start reading that, because it kind of lays out what to think about at the multiple levels of models and how to do some cross perspective views of it. So that's definitely a good read, and it's only less than 10 pages. So that's definitely a good starting point. When pulling that, as I think about then what is the kind of key data, I'd focus on parts of the programs that you know are uniform that are also reusable. And how do you build those out correctly such that other people can then reuse it to get the benefit? Once again, adding that value to another program is really where you're going to see that federated structure grow. Because if you can come in and go, look, we've already done this, all you have to do is reference this model. You bring in the SysML block, it inherits all of the state machine diagram properties and blah, blah, blah. And then you can simulate, like, that's the value they're going to want to see. So by focusing on that kind of foundational layer and then building that up, that's where I probably would start. Hopefully that answers your question.
No, thank you.
Hey, Daniel, Greg Piper here. So, kind of diving into this here with both feet, but I've got some fundamental questions around 5097 and kind of the directive there. It feels like some of the headwinds here are also, some fundamental shifts in how we do business, right? And so I kind of want to get your take on. I want to get your take on what you think the impact is, right? And the shift that has to occur between primes and subs and partnership with DoD. I'm primarily in the digital technology space and have been there for, close to 40 years. And so I get some of the shift and some of the technical steps we're going to need to take to be able to, share content and information like this. I think the discipline around engineering is coming very quickly in my organization, but I want to try to understand from your perspective if there's any headwinds there and if you see a fundamental business shift that's required.
So I see it, and I see it starting to happen. So part of my role is I'm involved with a lot of various science boards in the department. Another thing I never realized is that there's defense science boards, there's defense business boards, and there's Army, and the Navy. Everyone has a science board, and they've all been looking at digital engineering, and I've talked with all of them. Recently, I sat in on a defense business board briefing to their lead, and they spent a lot of time talking about the as kind of their paper that they're delivering up to DepSecDef, since all that came out of a DepSecDef action, was about the, hey, as this transition happens, the way we think about funding has to change. The upfront cost is going to be bigger. The workforce, you're going to have to go spend money to retrain your workforce, and it's the shift that it's going to happen. So that's happening already. There's been another report recently that actually talked about what would a different budgetary process look like versus the classic 5-year FIDEP approach. There's a whole history of the FIDEP and dating back to the Cold War and stuff like that. So the secretary is thinking about that. Congress is thinking about that. Congress directed us, and we replied in a report of what would a DoD Digital Engineering Center of Excellence look like, and how would it add value. So Congress is interested in all this. They're recognizing that as we think about the kind of near peer adversaries that we potentially have, that the way we do business, and that goes back to the kind of strategic priorities coming out of the president and SecDef, like, needs to start changing. And so there's just a lot of layers in there, but the direction and the headwind is gearing up towards going that way and rethinking about that. What I'm trying to do as I provide value is I'm working with like the DoD IP cadre, which is a lot of the lawyers and involved with the contract writing, because when we think about digital engineering, a lot of that sometimes gets into the data rights challenges of, well, great, and I've talked with system engineers at contractors, and they're like, we get told to deliver us the digital twin, and it's just like, what is that? What is the digital twin? And it's just like, somebody wrote that on a contract. And so it's like, how do I start educating that contract layer, the IP lawyers? How do we start framing some of that so we let the defense industrial base keep the right amount of IP, and us on the government side understand, well, what do we actually want to do with it? And so that way we can let you guys have your value, but we understand where that line needs to be. And so that's a lot of gray space in there, but that is something that we're working through.
I mean, and I'll just close with my final comment here. I mean, fundamentally, if you want to compete, right, you want to compete with BIDG, you want to grow, you've got to shift, right? You have to be able to shift and adapt and adopt this way of design and development and the sharing of those designs. So I get it. Thank you.
Yep.
So I know we're way over time, and I want to be mindful of your time, Daniel. Thank you so much for an amazing presentation, as always. Really appreciate you taking the time to present all of that to us. Just thank you. Excellent. Thank you so much.
Thanks, everyone.